So I'm going to go ahead and start recording here, and then we'll start talking about some of this information. If you're not familiar with exponents, there's two components there. You have a base and you have an exponent itself. It's a way to do repeated multiplication.
Is all of our work going to be online?
Yes. Yes, all the curriculum is based off of online.
What if you don't have Wi-Fi at home?
Yeah, that could be a problem for you. You have someplace you can go to get on Wi-Fi?
She was mentioned in the library.
So hopefully everybody can see this screen here with lesson objectives. Gives you a quick information on what the base and the exponent are. Again, it's about repeated multiplication. We can make big numbers and use whole number powers to figure out by computation what the numbers actually represent when we have an exponent. And we can do the repeated multiplication as powers. Exponents are often referred to as the power. 10 to the second power, 6 to the third power, etc. So the benefit of that using exponents is with big numbers. 3 to the second power, instead of writing 3 times 3, instead of writing 5 repeatedly times itself 4 times, you can write 5 to the 4th power. The large number is the base, the small number is the exponent. The reason that we have to start off with this information is because right away in this lesson, you start to deal with the order of operations. The order of operations is the precise order that we have to do math in. So you can see here with this example, you've got the base is the large number. The exponent is the little number that tells you how many times you multiply that base number times itself. It's 7 times 7. It's not 7 times 2. That's the most common mistake. People think, well, I'm just going to multiply this large number by the little number, and that's going to be my answer. Well, 7 times 2 is 14, but that's not what this says. This is 7 times 7. 7 to the second power is 49, 7 times 7. So you got to get used to dealing with these exponent terms as repeated multiplication. 2 to the third power, 2 times 2 times 2. It's the same as 8. It's not 6. It's not 2 times 3. Just gives you a little bit of a more explanation here on using these exponents. So if we have something that's already in exponent form, we know that it's repeated multiplication. So this example is 5 to the second power, or sometimes 5 squared. It's going to be 25. 5 times 5. If we have repeated multiplication and we want to write it as an exponent in the whole number powers, here you got 7 times 7 times 7, 7 to the third power. This is exponents come into play and are extremely helpful in a lot of scientific situations. For instance, if you're talking about space and the distance between the planets or Earth and the stars, you're going to use exponents because the numbers are so big. 3 to the third power is going to be 3 times 3 times 3. Well, that's 3 times 3 is 9, times 3 again is 27. Don't expect you to know that necessarily off the top of your head, but after a while you get used to it. So hopefully that helps you see how these exponents work. And I want to look at the next thing I want to look at is the order of operations. See if I can enlarge this a little bit. Part of the reason why we have to talk about order of operations right at the beginning is because this first unit is about expressions, simplifying expressions and solving equations. Math and algebra particularly is very particular, very specific about the order that you have to do things in. You see this phrase here, please excuse my dear Aunt Sally? Well, the idea there is it's intended to be an expression that can help you remember that order. Because in red there, 1, 2, 3, and 4, that is the specific order that we always have to follow. Whatever kind of a problem that we have, however complex it is, we have to solve the parentheses first, then we solve the exponents, then we do multiplying and dividing, whichever is first from left to right, and then we can add and subtract. Adding and subtracting is always last. You'll probably hear me talk more about combining positives and negatives. A negative or a minus mean the same thing to me. They're interchangeable. Every term has a sign. It's either positive or negative. The sign goes with that term. Positive numbers don't always have to have a sign. If it's at the beginning of a problem, you won't see a plus sign in front of a positive number. But we get stuck thinking about only adding and subtracting sometimes. It can make some of these problems more confusing. And this next piece here where it says multiplication and division are inverse or opposite operations, that is critical for being able to solve equations. Because we use opposite operations when we have to cancel out a term. Multiplication and division are the opposite. Inverse is another way of saying opposite. Addition and subtraction are opposites. So we use the opposites a lot. So here with this focus question, you've got 8 divided by 4 minus 2 divided by 4 times 2. What are you going to do first? Yep.
4 minus 2.
Parentheses first. The thing about algebra and with this order of operations is it's not like reading a sentence. When we're just reading this sentence up here, we're going to start on the left and we're going to go to the right and we're going to get whatever we get. This problem has to have the parentheses solved first, because what you end up with is 8, I got to use a dash here, divided by that parentheses number. 4 minus 2 is 2. We got another division, divided by 4 times, whoops, no, times 2. So now the only operations that we have left here are division and multiplication. So that's where this part of the rule comes into play. I know PEMDAS, please excuse my dear Aunt Sally, appears to have multiplication in front of division, but the way it's defined, we do whichever one of those operations is on the left. So we first have to do 8 divided by 2. 8 divided by 2 is 4. Bring the rest down. Now we got 4 divided by 4. That's 1. Final answer is going to be 2 after all of that. And we have to follow PEMDAS exactly in order to get the correct answer in each of these kind of problems. Anybody have any questions so far? So if you look at this next problem, focus question 2, there's 3 different sets of parentheses there. Anytime you see something like that, we have to start with the one that's on the inside the furthest. So we got to do that one first, 9 minus 5 first. And then we just do them in order until we work our way out of all the parentheses. 2 minus 1 times 6 minus parentheses, 4, whoops, only 1. Okay, we've solved that one. So I can get rid of that parentheses, but we still have 2 left. And then all of that's divided by 4. The next parentheses is this one. 1 times 6 minus 4. And even within the parentheses, we still have to follow PEMDAS. So we don't do 6 minus 4 first. We do 1 times 6 first. 1 times 6 is 6. Minus 4 is 2. And then we divide that by 4. Last parentheses remaining, 2 minus 2. Is all that's left, 0 divided by 4. Should end up with 0. Seems complicated, but again, if you're not sure what step to take next, then go back to PEMDAS, PEMDAS. Please excuse my dear Aunt Sally. Okay, so let's back to the Odyssey where. Sure. That was strange. Oh, I know. Probably logged me out. So what you're going to see when you get into the Odyssey-ware, there are various videos that are included. If those videos aren't adequate enough for you, people that have been around for a while with me know that I like Khan Academy. Yes. Is that a school computer? I really don't know. Hang on just a minute. I don't really know how to. Can you go down and see? Do you know who your coach is?
Yes, she's teaching them in the math class right now. I think the password is your birthday. Is March of 14 to 2002. On that silver paper. That's what I tried using, but I couldn't change it. And I like didn't use it.
You didn't write it down? Yeah, I don't know if I don't know how anybody's going to help you with that.
Could it be your Facebook password or Instagram, Twitter? I unfortunately don't know. I usually have everything written down. I don't know why I didn't write this, but.
Well, There you go. Back to what I was doing before. Trying to explain a little bit about how Odysseyware is put together. You got these different videos. If you have trouble with explanations, there's below each video is this link, this button that says show transcript. It can give you the actual word by word description of what's going on in that particular video. So be sure you use that. Go click on that if you need to look up a word or you don't understand something that they're saying in the video. So we'll look at this first one here about using the order of operations.
The order of operations is a process used to evaluate or find the value of a numerical expression. It outlines the order in which each operation should be done in an expression. This makes certain that each expression has just one possible value. Parentheses and other grouping symbols such as braces, brackets, and the fraction bar are completed first. Next, exponents are evaluated. In the third step, all multiplication and division is completed from left to right. And finally, addition and subtraction is completed from left to right. Let's use the order of operations to evaluate this complicated expression. The fraction bar indicates division, but it is also treated like a grouping symbol. So we will need to first evaluate the numerator and denominator of this fraction separately. Let's start with the numerator. In the numerator, we have both parentheses and brackets. We always work inside the innermost set of grouping symbols first. So we'll evaluate the parentheses first. Inside the parentheses, we have both an exponent and subtraction. The order of operations tells us to find the value of the exponent and then subtract. 1 raised to the 4th power is the same as 1 times 1 times 1 times 1, which is actually just 1. Then 1 minus 1 is 0.
Try it.
Now let's work inside the brackets.
Maybe
Inside
you'll
the
test
brackets,
out
we have
something.
both subtraction and multiplication. The order of operations tells us to complete the multiplication first. Remember that any number multiplied by 0 is equal to 0. So 7 times 0 is 0. Then 8 minus 0 is 8. Finally, we can complete the last operation within the numerator, multiplication. So 5 multiplied by 8 is 40. Now let's find the value of the denominator. The order of operations tells us to complete the exponent before the addition. 3 squared is the same as 3 times 3, which is 9. Then the sum of 9 and 1 is 10. We're ready to finish the problem. Remember that the fraction bar is another way to show division. Since 40 divided by 10 is 4, the value of the original numerical expression is 4.
Now, I don't know if you noticed or not when she's setting this problem up and describing it, you see a couple of different styles of parentheses there. She called these brackets, but sometimes people set up problems and show different styles of parentheses. You still have to follow the PEMDAS process in solving the ones on the inside the most first, regardless of how many different sets of parentheses that you have. So they might be shown differently, they might look differently, but the process is still the same. Lots of examples there. If you work through those examples, you're not understanding something, that's where you probably need to text me. Now, for those of you that have been in Odysseyware before, you know that there is a message function. You can send a message to me, but if I'm not on Odysseyware at that moment, I'm probably not going to see it because Odysseyware does not notify me. I don't have any way of knowing that you've sent me a message until I log back in the next time. And I will respond, but it may not be immediate. So if you're working on something, especially during normal school hours, it doesn't matter if it's Monday, Tuesday, Wednesday, Thursday, or Friday. If it's during normal school hours, the best way to get my attention is going to be by sending a text. So my phone number was sent in one of those first emails. So that's the best number to reach me by text. if you have a question about something or you need some specific help. The other reason that that's important is because on Mondays and Wednesdays, sometimes on Fridays, I'm available to set up individual Zoom conferences if you need extra help. I won't be in the building on Mondays or Wednesdays, but we can get together virtually if you have something that you're still struggling with. The best way to get me for those is by sending a text. You'll see once you're into OdysseyWare, you've got lessons and then a quiz, lessons and then a quiz. One thing that they've added this term is we now will have a final exam. It's not going to be in OdysseyWare. There are 3 units in Algebra 1 to complete. We're in the first one now.
So the final for like the year or whatever, that's not going to be on Odyssey?
Nope. We'll probably do that through Google Classroom or some other means. I haven't figured that out yet. But we only have to do these first 3 lessons here. We're in expressions, equations, and inequalities, followed by linear functions. That's where we start to get into graphing. And the 3rd unit is systems of linear equations and inequalities. Polynomial functions and radical and exponential functions are part of Algebra 1B. So if you know how to deal with PEMDAS, you're going to be able to simplify expressions. Expressions do not have an equal sign. That's why the only thing that we can do is simplify them.
The distributive property is often used to simplify expressions that contain parentheses. Remember that the distributive property states that a factor on the outside of a parentheses gets multiplied by each term inside the parentheses. For example, 3 times the sum of x and 7 can be simplified by multiplying 3 by both x and 7.
And here's a perfect example of an expression. There's no equal sign in that expression, 3 times the quantity x plus 7. But we can still simplify it and get rid of the parentheses. Now we can't solve the parentheses. We cannot solve the parentheses and follow PEMDAS specifically because we don't know what x stands for. X is the variable, but most common variable that you see in algebra. Could stand for anything, but we can still do this multiplication according to the distributive property. So what she's talking about here is distributing this 3 against the x by multiplication and adding it to 3 times the 7.
Resulting in the expression 3x plus 21. Let's try some other examples together. When simplifying algebraic expressions that contain parentheses, first use the distributive property to remove the parentheses. So, in this example, multiply 2 by each term inside the parentheses, which results in 2n minus 18. The next step is to combine the like terms.
Now we can simplify this further because we know what negative 18 and positive 10 are if we combine them together. You notice how I said negative 18? It looks like a subtraction problem, but that minus sign goes with the term 18. So if you could turn this around if you wanted to, you could say 10 minus 18, it means the same thing. Those are like terms because they're both just integers. We cannot combine it with the 2n because that is 2 times n, and we don't know what the n stands for.
The only like terms in this expression are the constants, negative 18 and positive 10, which combine to equal negative 8. Now our algebraic expression is in simplified form. Let's look at the next example. Again, Begin by using the distributive property to remove the parentheses. So multiply -4 by both y and 2. Now combine the like terms.
And in this example, the like terms are actually the ones with the variables. This -4 times y gives you a -4y. The -3y is separate. It's not part of this distributive property problem, but we can still combine those. -4y combined with -3y gives you -7y. But that's as far as you can simplify it.
The sum of -4 and -3 is -7. This expression simplifies to -7y minus 8. In this
Anybody have any questions so far about combining like terms using the distributive property? A lot of examples here in Odysseyware for that. So the next piece here about simplifying expressions involves grouping. It's not loud enough.
Dan is putting together a jigsaw puzzle, first combining those pieces that look alike, the sky, then the water, then the trees. Finally, he puts all the parts together to make one puzzle. The same process is used in mathematics. Sometimes it is necessary to combine parts together like a jigsaw puzzle. If you keep at it, the puzzle, or problem in this case, will eventually come together. Let's simplify the expression 3 plus 6 times the quantity x plus 2. The first thing to do is get rid of the parentheses if possible. In this case, use the distributive property. Then combine like terms. At this point, if you knew what 15 plus 6x equaled, you could ultimately solve for x. Now, let us simplify the expression 3x minus 4 times the quantity x plus y minus 3. First, use the distributive property to remove the parentheses. As you can see, the distribution is -4, not +4 because of the minus sign. Now combine like terms, which in this case is 3x and -4x. The simplified expression.
I'm not understanding why all these videos are glitchy on me this morning. The other thing that you'll see once you get into
-1x minus 4y plus 12.
Wow.
Simplify the expression 2xy plus 5y minus 5xy minus 2. First, move the terms around to get like terms near each other. In this case, move the 5xy to be near the 2xy. You can do this because of the commutative property.
The only thing I want to add here is if you notice these symbols here with multiple variables start to get more and more complex potentially. And so you really have to look closely at these to determine which ones are the like terms. These two both have an x and a y, so those can go together. This is only 5y, that's only has a single y, so it's not like the other two. It has to have exactly the same letters and exactly the same exponent levels in order to be considered like terms. You'll see that a lot in these kind of problems. So what I started to say here is there's going to be plenty of examples here as you work through these multiple choice questions. If you, like question number 16, it says simplify 8 times the quantity A plus 2B plus 6 times the quantity 2A plus B. You've got two different distributive property problems there. You're going to have to solve each part of that and then look to combine your like terms. The last part of this lesson is about equation solving. Now you're getting into situations that do have equal signs and where you have to take some other action in order to solve the equation. The whole goal for our equation solving is to isolate the variable. So here they've taken a written phrase, a number was multiplied by 2, and then 4 was added to it to get the result of 12. So here's the equation that is translated into. 2x, which is the number, a number, we don't know what it was, plus 4 equals 12. Now from here, you have an equation with an equal sign that is solvable. We can find what x is, and here you start using these opposite operations. In order to get the x by itself, all the other terms that are on that same side have to be eliminated. So we need to use the opposite of a plus 4, which is minus 4 or negative 4. Those cancel. There's something that we refer to sometimes as the golden rule of algebra. Whatever you do on one side of the equation, you have to do on the other. So if you take 4 away from one side, you have to take 4 away from both sides. Now you do your little calculations and you've got remaining 2x equals 8. Here they're showing that you can multiply by the reciprocal. It's not typically what I teach. I like to look at this as dividing by 2 because here I have 2 times x. So if I'm sticking with my opposite operation there at that stage, I'm going to divide. I don't want to have to try to remember what a reciprocal might be. But same thing. If I do it on one side, I have to do it on both sides. So once I divide both sides by 2, I have x equals 4. This next example here is a really good one because it's got a fraction in it. And the fraction has our variable tied up into it. So the first thing that we have to eliminate is that plus 7. We want to get rid of that from the left-hand side. So we're going to subtract 7. And I'll show you here on the whiteboard what that means. So we have x divided by 5 plus 7 equals 22. So that's our equation. Our variable is tied up here in a fraction. So I gotta get rid of this 7 here first. In order to do that, I'm going to use the opposite of a plus 7, which is minus 7. Do the same thing on both sides. 7 minus 7 here gives me 0, so that's canceled out. On the right-hand side, 22 minus 7 gives me 15. So the next row down, x divided by 5. What's remaining now in my problem is x divided by 5 equals 15. One thing that you'll hear me ask quite a bit in this class is what kind of a problem is it? So if I asked you about this right here, this x over 5, if I asked you what kind of a problem is that, your response should be, well, that's division. So if it's division, which all fractions are division, now our opposite's going to be to use multiplication. So I'm going to multiply both sides now. I'm going to show this left side in a parentheses just to make it obvious. And I'm multiplying everything on that side by 5. And on the other side, 15 times 5. So here, because I'm multiplying this fraction, then my 5s are going to cancel. And I'm left with the solution of 75, x equals 75. And if you're not sure that you have the right answer, the thing with equation solving in algebra is you can always take your number, whatever you believe x to be, plug it back into the original equation and see if it gives you a true answer in the end when you do the calculation. So 75 divided by 5 is 15. Add to 7 to that, you get 22. So I think I've got the right answer. So lots of two-step equations here. Some of them are going to have fractions in them like that. So you got to really pay close attention to what opposites are being suggested here in the examples.
Thank you.
Okay, let me know if you need help.
The construction of any good house starts with a basic foundation, the ability to solve word problems. Problem starts with a foundation in properties. The distributive, addition, and multiplication properties work hand in hand to allow you to solve many different types of problems. You need a good foundation to solve these problems. Solve the equation -8 minus 4 times the difference of 12 and 3d is -8 for d. The first thing that needs to be done is to get rid of the parentheses. You can use the distributive property to distribute -4 to both.
So what he's showing you here is this -4. Remember how I said the sign goes with the term? This is a perfect example of that, because you're not just going to multiply the 4 times the 12 and the 4 times the -3d. It's the -4 times 12 and -4 times -3d. You have to take that sign with the term, because here, if you don't, you're going to get the wrong calculations, because those signs are critical. More mistakes are made over having the incorrect sign in algebra than about anything else. That's just historically what I've seen. So watch those signs.
Use the distributive property to distribute -4 to both terms inside the parentheses. Remember, the 4 has a negative sign with it for the multiplication. Join like terms, in this case, the numbers without variables. You can now add 56 to both sides using the additive property. To get d by itself, divide both sides of the equation by 12 using the multiplication property. 48 divided by 12 equals 4.
And that division there is almost always the last step on these kind of problems. Because if you want to get, this is a multiplication problem. That 12d, let's see if it, 12d, that's 12 times d. So that would be where you want to ask yourself, what kind of a problem am I talking about here? What kind of a problem is this? And so it's multiplication, divide, division is the thing that's going to be your opposite to solve. Yeah.
So wouldn't you do 12 divided by 12 on one side?
Yes. Well, not 12 divided by 12. You're going to divide both sides by 12. On the left side, you'll end up with 12 divided by 12. On the right side, you'll have 48 divided by 12.
That's
Oh, yeah.
okay.
Yep. Yeah, I think he shows that next here. And that's why this is a good example also of how sometimes these operations look like fractions. Because a division problem is a fraction. A fraction is a division problem. You can always write it that way.
Multiplication property. 48 divided by 12 equals 4. Aiden bought a shirt for 20% off the original price. If Aiden paid $15 for the shirt, what was the original price? To determine the original price, we need to make a model. The price Aiden paid can be found by taking the original price of the shirt, then removing 20% of the cost. Remember, when you see the word of, it means multiply. 20% is the same as 20 divided by 100, or 0.2. Creating a model for Aiden to solve, you get 15 15 equals the original price minus 20% of the original price. Add like terms. In this case, terms with P in them. Now, 15 equals 0.8 times P. To get rid of the 0.8, use the multiplication property and divide both sides by 0.8. Using the symmetry property, we can switch sides so the variable is on the left. The original cost of the shirt was $18.75.
So you're going to see a lot of examples like that and a lot of opportunities for practice throughout each of these lessons, okay? And so use those multiple choice questions to find what you need, get more practice. If you're still having trouble, I'm going to go back and show you where I would recommend that you go. Some people don't like this particular site, but I found it to be extremely useful. Before I mentioned Khan Academy, hopefully everybody can see this. If you notice up here in the right-hand corner, this is my Khan Academy page. I have an account with Khan Academy that I created with my Google address a long time ago, way before I came to the Excel Center, probably 10 years ago now. And Khan Academy keeps track of everything that I've worked on or that I've used in class, and it gives you all kinds of information. If you're not sure what to look for, there's this search box up here. Solving equations, quadratics, no, I don't want quadratics. Solving systems of equations, no, don't want systems either. So that didn't help too much. Find another one. Single variable equations, or maybe just equations. And you'll find after a while, okay, here's linear equations. You'll find after a while that you've got videos, you've got other practice things that the website will actually score for you. So if you need more practice on something, it will tell you right away if you got it right or not. And it will score it for you and even give you hints if you need it. If you have trouble from there, there's other websites that I can point you to. The other thing I want to mention about the Odysseyware is you're working at your own pace. It is set up so that you have 5 chances to pass each quiz, and you'll be stopped after 5 chances if you don't get it right. What I would like to see you do is contact me before you get to that fifth attempt, because if you're continuing to do things wrong, doing it wrong again and again and again is not going to help you learn it. So I see Nura's question there. No, you don't have to finish today. Again, this is on your pace. What you'll see is that the completion dates are built into Odysseyware. So if you get behind, it will tell you. It will tell you that you're behind so many lessons or what have you. And there are due dates that are built into the Odysseyware program, into the curriculum. I look at those sometimes to see who's staying current. But what we're going to try to do is to try to get through at least 2 lessons per week. That way we'll use our Tuesdays and Thursdays effectively. And hopefully that will be enough to get you through to the next lessons where you can continue to practice and continue to get those quizzes completed. So I'm going to stop the recording right now. I see some other questions here.